Hi, I'm Maxwell. I'm in grade 12 STEM, and this is my active aerodynamics capstone project. The goal of this project was to build a rear wing for my car that can adjust itself depending on certain conditions. A rear wing on a car produces downforce, which presses the car into the ground, increasing traction and controllability. Basically, a car with more downforce is able to go faster around corners and maintain control at higher speeds. This is evident in F1 cars, which have tons of wings and tons of downforce, which let them go around corners very quickly. The issue with wings and other downforce-producing structures is that they also produce drag, which slows down a car and makes the engine work harder to maintain speed. In order to counteract this issue, I made a wing that can adjust itself depending on how fast the car is going. By changing the angle of the wing, you can optimize the amount of drag and downforce produced. For example, at high speeds, the wing flattens out to produce less drag and less downforce. This allows the car to go faster and use less gas. While slowing down to enter a corner, the wing increases its angle to produce more drag and more downforce, helping you slow down while allowing you to take the corner at a higher speed. To make this system work, I had to make a speedometer connected to a servo motor. The speedometer uses a sensor to track the rotation of a small magnet that would be attached to the inside of the wheel. Using the time of one full rotation and the circumference of the wheel, the current speed of the car is calculated. When certain preset speeds are reached, the servo motor is activated, rotating the wing in small increments for each speed. In this project, of course, I also had to design and build the actual wing. In order to form the airfoil shape, I cut 9 ribs out of aluminum. The main structure is made out of insulation foam, which is sandwiched in between the ribs and sanded down to match. As a main structural support and an axle to rotate the wing around, there's an aluminum tube that goes down long ways in the center of the wing. Finally, the entire wing was coated in carbon fiber for extra strength and a clean-looking finish. The project was a success and functions, although only at speeds below 99 km per hour. Due to hardware limitations, it's impossible to rotate the wing beyond this speed. Although it works as a wing and a difference can be felt while driving, there is missed potential regarding efficiency, as the wing cannot be rotated to a low drag position when it's needed most. In order to fix this issue, I would need to connect the servo motor to the analog speedometer built into the car, or simply purchase and install a digital one and get it to talk to the servo. Given more time, there's a few upgrades that I would make. The ability to fully rotate the wing into an air brake position while braking could be very useful. It would allow me to slow down faster and lengthen the lifespan of the brakes. Another useful addition would be a gyroscope, which would allow the wing to rotate based on acceleration, deceleration, and g-forces. This would allow the wing to sense deceleration and activate the air brake mode, as well as sense when the car is entering a high-speed, high-g corner and increase downforce accordingly. That's all I've got for now. I hope you enjoyed, and I look forward to continuing working on this project over the summer.